Hello, welcome to BensTechLab. This is probably going to be one of the first videos on my channel, not because it's the best video, but because it's one of the easiest ones to edit. Isn't that the reality? Hey, I've been working on my home lab for a little while now, since March 2020 or so, a little bit before that. Got a little extra time at home. I've been working from home since March. I'm a software architect by day, and I can work from my home office, which makes it really great considering the state of the world. But I want to learn some new things in my home lab. Most notably, I want to play around with Kubernetes and learn a bit more about load balancing and scaling and some of the kind of cloud functionalities that you can play with there. And I watched a video from Jeff at Craft Computing, who put together 3 home lab servers for under $1,000 US, and he was using a bunch of used and or remanufactured products from China on eBay or AliExpress. And so that gave me an idea. I was originally going to build something with maybe some AMD EPYC processors or something like that, but the costs get up there really quick, and really I just want something cheap to play with that's commodity hardware that can let me play with multiple nodes in my Kubernetes cluster. So I followed some of Jeff's advice there, and I picked up some cheap Chinese motherboards. So let's give you a shot of that. This is a Machinist X79G. And today all I'm going to do is basic DOA testing. These things all come with like 30-day warranty from the sellers, but the longer you wait, the less likely you'd ever get any kind of support out of them. So we'll take a look here at what we got. There's a SATA cable in the box. There's also the back plate in the box there. And there is the motherboard itself. Let's give you a shot of that there. I think it looks all right. Not too bad. It is an interesting standard because it's fairly compact. It's not micro ATX or micro ITX, sorry. It is micro ATX, which is, and it's actually a slightly smaller variant of micro ATX, so it's closer to flex ATX, although it doesn't seem to line up exactly to either of those standards when I look online. So, but it is pretty compact, so I can fit it into a small case. The cooling looks acceptable in terms of the chipset cooler here and the VRM cooling here, but I've seen a lot of complaints that the VRMs on these Chinese motherboards are not amazing. So we will do some testing on that later. I've got a non-contact infrared thermometer coming from Amazon in the next couple of days. So we'll do that when we get a full system build. I haven't even bought a case yet or any of the other kind of surrounding components, but I just want to test these while I've still got a chance to return them if there's any problem with them. This motherboard comes with this cooler adapter, which allows you to use kind of cheap AMD AM4 coolers, the clip-on ones, with the LGA 2011 socket. I've gone ahead and bought, I did buy a Snowman cooler from China just because I thought it was kind of mandatory to have one on hand and know what it's about because it's super cheap. And if you're looking for the cheapest build you can get off of eBay or AliExpress, that's where you're going to end up with, is one of those Snowman coolers. But I also wanted to test specifically the fan control on this motherboard with a more compact cooler. So I'm going to take this adapter bracket off here. And I did buy this cooler brand new. I bought this one because I want to try to put my whole server into some narrower cases. So something like a Sliger Cerberus case, or perhaps even an N-case M1. The reason being I want to stack up three nodes in my home lab, and I do not have a full-size network rack like some of the other home labbers out there, and I'm trying to keep it relatively home friendly and quiet. So this is a Noctua brand, which is going to be quieter than a lot of other coolers I could go for, and so I want to see how that works on this motherboard. And I want to test that the Chinese motherboard supports thermal based fan controls in the BIOS. Some of the BIOS features are known to be a bit lacking, so I want to check that out and see how that works. So we'll get a chance to test some of the components here today, find out if the fan control works, and then I'll be able to decide what case I want to order. Okay, so for memory, I have 4 sticks here of Crucial 16 gig DDR1866 memory. These are used from China, so they're going to be reclaimed out of production servers that have been moved offline or deprecated. They are DDR3 registered ECC, and they should work on this motherboard. So we're going to give those a go here. I am going to populate all 4 slots. So my processors that I chose for this are Xeon E5-2650v2. This is the ones that Jeff at Craft Computing used was 2648L, which is a lower power 65 watt TDP rated processor. I went for the 2650v2 because it was one of the kind of best bangs for your buck in terms of price to performance ratio. There is the possibility that the VRM cooling on here won't keep up with that, but at the same time, because I'm using these for virtualization and or Docker and just for a home lab for playing around, these are not going to be running all cores hot all the time. So there's a good chance that even though it is capable of exceeding the capacity of the cooling on the VRM, that I won't actually hit that in regular use for home labs. So we'll give it a go, see how it works. If I have any problem with the cooling on the VRM, then maybe I will downgrade to a slightly less power hungry chip than the 2650v2s. But we'll start there. So they always say to inspect your socket when you receive it, just to make sure that there's no damage on there. Pins look pretty good. So I got 2 of these motherboards so far, and I got 2 2650v2s. I may end up building 3 nodes in my cluster, but this is just what I went with to start. The processors are obviously used, they're reclaimed. So these would have been in production since around 2013 till a couple of years ago maybe, depending on what company was using them. But hey, you never know, it could be Cloudflare. Cloudflare used to run the 2650v2s before they went with all AMD EPYCs in the last couple of years. You'd have to look on their blog to see what the date was. So you never know, this might be out of Cloudflare infrastructure. I don't know where they source all of their used computer hardware. But this is a 2650v2, and I'm going to put it in on this socket here. It does come with some thermal paste. This is probably not great thermal paste, but just for checking DOA on when you receive some product, it's perfect because it's throwaway. You can use it for 15 minutes to make sure the processor works, the motherboard works, and then when you're ready to build your full production build, we'll use the Noctua thermal paste. We'll save that for the real build when we're good to go. So let's see here. Triangles up here on the top back of the board. All right, so we're going to use this free thermal paste that came with the processor just for our DOA test here. Get about a P on there. That's about all there was in the pack. Let's open up our Noctua here. That's nice. So this is one of the top recommended coolers for people who are interested in the compact cases like the Ncase M1 and the Sliger Cerberus because it has a fairly low overall height. That is if you're not doing liquid cooling. I'm trying to keep this pretty simple, so I'm not going to go too far here. It did come with a little protector on the bottom, and it's got a nice little mirror finish on there, so it seems pretty good. We'll pull off the fan for mounting. It'll do. All right, so the Noctua cooler comes with all sorts of little adapter brackets here. So it can be used on all the common Intel 11X and Intel 20X processors, as well as the AMD AM4. I liked that when I was looking at it because it means that if I keep doing various computer builds over time, I could reuse the cooler anytime that I want to. So if I get one of those fancier cases, don't have to worry about it being obsolete before my computer parts are. So these motherboards do ship with no CMOS battery. Something about shipping regulations, because you can't have a lithium battery in post these days. So there's a little battery socket there. You have to buy your own battery. So these are just a CR2032, which is pretty ubiquitous. You can buy them all over the place. So for storage, I got this. This is a no-name brand. Well, it's a Chinese brand, Asenno. It was literally the cheapest one that I could find that was an NVMe and not SATA. It's really not a lot to them these days, eh? Let's get our fan back on here. And then the graphics card. I've got a few to test here, but this is a Zotac GeForce GT710. The reason for choosing this one is it has a PCI Express by 1X connection on there. The 1X connection is obviously not going to be that performant when it comes to gaming or multimedia, but this is essentially a headless server. So the purpose of having any graphics at all is just to be able to use the BIOS and do some basic setup with the console. But after that, I mean, I really don't need graphics performance on here. So I'm going to go ahead and try this PCI Express by 1 card for our graphics today. And last but not least, we need to do some power. I got something cool in store for the power here. Let's take a look. I actually bought these for a previous project and didn't use them. I ended up upgrading. This is a Plex fanless 200 watt power supply kit. There's 2 components. The first component is like the Pico PSU style thing. So give you a shot of that here. So this is just a small 24-pin ATX plug. All the components are built in here with some heat sinking on the front and back, and power input. It's got a couple of outputs on the side, one for a graphics PCI Express rail, one for a motherboard rail, and then one little SATA connector if you need it. Pretty cool little compact fanless power supply here. A lot of the commodity ones you'll find on the market are rated for like 100 to 150 watts. This one goes to 200 watts. It's just a little more premium. It's got a little more heat sinking, a little nicer components on there. We do need the motherboard connection here for a little extra power. Okay, so how do we get power to this thing? This converts basically a wide voltage input, like around 19 volts, which is what the Dell laptop power bricks put out, to the correct 5 and 12 volt and 3.3 volt, whatever the motherboard needs. But HDPlex does also make this power brick here. It is a fanless brick. It is a AC 200 watt 19 volt power supply, 10.5 amps out. It's got the standard power connection there, but it is removable, so you can switch it out for various countries. And then on the output side here, it's just going to have a little Molex connector to connect to that. So we will do that. Gonna get some graphics going here. Put some HDMI in here. That PCI Express by 1 slot is certainly not stable on this nice open air test bench here. We'll grab us a keyboard and mouse. So most of the gotchas with these Chinese remanufactured motherboards have to do with feature support that I don't care about. So some of them include no USB 3 on this motherboard, it's all USB 2, and the performance is not going to be excellent. But I'm not doing this for external storage like USB drives or anything like that. So they're really only going to be used for keyboard, mouse, that kind of thing. They also have problems such as not doing sleep mode properly in Windows, being able to sleep and hibernate and come back from that. They just like to stay running, which again for a server is just great. So I don't have a problem with that. The one thing that I do want it to do properly is fan control on the CPU, because I want it to run quietly most of the time and just ramp up when needed for cooling. So that's what I'm aiming to test here today. All right, so we got a keyboard, we got a mouse. We've got graphics hooked up here. It goes. So we're getting about 30 to 50 watts there on boot. There we go. It certainly took a second. I don't know if that just took longer than normal to get to the BIOS screen because I had just put in the CMOS battery. I did hear the fan go quite fast to start, and it is ramping down right now. So that's a positive sign to see that the fan control works. It looks like when we're just sitting idle here, not even booting into an OS, we're sitting at around 52.7 watts. So in terms of just general system baseline load for the graphics card, memory, and NVMe drive and processor just existing but not doing work, we're sitting at around that 52.5 watts there. So let's go ahead and restart. There we go. All right. Cool. So it's alive. That's good. Total memory 65,536, DDR3. That's a good sign. That means all four of my RAM slots are working. RAM sticks are working. Let's go ahead and play with this a little bit. So it does say that there's a hibernation state that you can turn on and off in the BIOS here. I've been told it doesn't work properly. I'm going to leave it disabled for now because this is being used for a server purpose. We're going to do suspend disabled, hibernation disabled. CPU configuration. So there it shows socket 0, Intel E5-2650v2 at 2.6 gigahertz. That's good. It's got a bit of other information in there. Minimum speed 1200 megahertz. Processor cores 8. That's good. Intel HT and VTX both supported. That's good. Looks like this processor is working okay. Hyperthreading is enabled. Active processor cores all. Hey, that's interesting. So perhaps if you run into cooling issues, you could always drop down a couple of cores if you're just using what you got on hand. I'm really just testing that this thing is not dead on arrival. But I'm curious what's in here. Power technology, custom, speed step, turbo mode. So turbo mode is enabled. Some motherboards can have problem with it actually reaching turbo mode, so we will test that, but it'll be a separate video when I actually do the full build here. We'll throw Windows on there just to run a few tests. So I'm not going to change the long duration power limit, long duration maintain, short duration power limit. Hardware monitor. So I'm going to do a proper test of the thermals on this motherboard later in the week. I've got a no contact infrared thermometer coming from Amazon, and I'm going to use that when I'm actually doing some load testing on here, so I can check how hot the chipset gets, how hot the VRM cooler gets, because those items are passively cooled right now. But I am curious to see here, so we've got smart fan function enabled, and the fan is going considerably slower than when it booted up. It says it's doing 1000 RPM or so right now. which is not bad. Actually, as a test, let's just turn this off and see what happens. Probably doesn't change until I save. Let's see here. Oops. Okay, so I turned off the the smart fan, and with the smart fan turned off, it looks like this Noctua NH-U9S is going at around 2000 RPM. It's noticeably louder for sure. It's reporting the CPU temperature at 30 degrees Celsius, system temperature at 35. Again, some of these motherboards don't always report accurately, so we're going to test that with a thermometer later in the week. I'm going to put the smart fan back on. Let me see what this function is. Automatic mode. It's interesting that they show two fans in here with smart fan, because the second fan header on this board is just a 3-pin fan header. The CPU fan header is the full PWM 4-pin fan header. Nice. Leave that alone. NVMe, so it is showing the NVMe SSD at 128 gigs. This is that Asenno NVMe. We'll maybe do a little test of that when I do the full system test here. There's the Realtek NIC. Grab the MAC address out of there in case you want to set up an assigned DHCP address. Shows the memory at 1867 down there. That's nice. It is 1866 memory, so it's picked it up just beautifully. All right, well, I've basically just turned back on the smart fan, and we'll see that it drops back down from 2000 RPM. All right, so we've achieved the goal that we set out for today, which is just to test that none of this hardware was dead on arrival, ordering used stuff off of eBay. It seems to be working great. The power is fine. This PCIe 1X card works fine in the PCIe 1X slot on this motherboard. The fan control works, which means I'm happy to use this motherboard as a home lab server in a place where it's got to sound good for being used in the house. I don't have a full-size network rack like some of the other home labbers on YouTube. I've got a small mini half rack that's wall mounted, so I do want to keep it nice and quiet and cooler, and that should do for now. I'm going to do a follow-up video pretty soon where we do full testing under load. So I will install Windows on here just to run a few benchmarks, and I will run some thermal tests. So I'm going to be measuring the temperature of the chipset and the VRM as well as the CPU, and comparing that to the reported temperatures by the BIOS to see if there's any lying going on in the temperatures. So far though, I'm happy with it. I'm going to tear this apart quickly. I'm going to test the other processor that I got here to make sure that it wasn't dead on arrival. I've also got a second motherboard here, so I got to test that to make sure it's not dead on arrival. If you'd like to see the full system tests, make sure you subscribe to the channel. I'll be posting those in another week or so with thermals. And if you like the video, hit the like button. It helps me out. I'm a new channel and just getting started, and any little bit of support that I can get is much appreciated. Hope you enjoyed the video. But for now, we'll see you in the next one.